In this video, we're going to be looking at cross-sections and revolutions. For the first part, we'll be looking at cross-sections. The later part of this, we'll discuss what the revolutions are. When a plane passes through a solid, which is just another way of referring to a three-dimensional figure, the intersection is a cross-section. Okay, so you can think of a plane as really like slicing through that solid item, and if you open it up, the part that you would see would be the intersection of that plane and the solid. That's our cross-section. For many of the traditional solids that we have, like cubes, prisms, cylinders, spheres, maybe even cones and pyramids, the cross-section that you get will be one of our traditional shapes. Now, you can create all kinds of really interesting shapes, but most of them tend to be squares, rectangles, and triangles. For example, here's a picture of a cube with planes passing through it at different angles. And depending on how it passes through that, you get different cross-sections. Okay, so if you go horizontal to the bases, your cross-section is going to be right here. Let's go ahead and highlight it. It's going to be right here, which itself is a square. Okay, now if you take that plane and you cross it at a diagonal, you're going to end up getting a rectangle. Okay, so let's try and highlight that one here. That does not turn out to be a square because the side lengths will be different. The length of that segment would match this one. You would get right angles in here, but the length of that side and the other one over there will be a little bit longer. And that you can actually easily prove using Pythagorean theorem, because if you look at this side right here, you would create a right triangle with that being the hypotenuse. In fact, you'd have an isosceles right triangle if this were a perfect diagonal cross-section. Okay, take that diagonal plane and shift it over a little bit. You can actually just cut off a corner of this, which would give you a triangle cross-section. Okay, and depending on the tilt of that, you could get an isosceles triangle, you could get an equilateral triangle, you can even make it scalene. For example 1, I'm going to attempt to do something. Just attempt to do it, and we're going to see how well this actually works out. What I want to do is take this horizontal plane and slice it through this prism and this cylinder and show you what the cross-section would look like. Okay, to do this, and this is the first time I'm actually trying this. Okay, to do this, what I'm going to try and do is cheat a little bit and take a copy of this plane and then just trace it around the figure and see if that works out. Okay, so I have a copy of the same images. I'm going to try and position it behind it in a good location. And also try and keep it lined up with that one, just for the sake of making it look nice. Okay, so that might work, and you can probably see it just slightly in the background. Okay, what I'm going to do is first start by tracing the outline of it. Okay, now it does go behind the figure, so I'll just stop there. Go ahead and connect these together. The back is also going to just stop once we get to that spot. Okay, so I've sort of got the plane built around it. And then I got to think about what the cross-section will actually look like. Okay, so I'm going to create a segment that would be parallel to that, which I pretty much just eyeball here. Okay, and that'll go around the figure. All right, so when that plane cuts through, when it cuts through this thing here, it should leave you with a cross-section that looks like that. In this case, assuming that the base is a square, then that means that your cross-section is a square. If it's a rectangle, sometimes you can't really tell with the depth of these things. If it's a rectangle, you will get a cross-section rectangle. So if I do take a horizontal plane and I cut through it, the cross-section is going to look exactly like the top and the bottom base, which will mean that for the cylinder, my cross-section should look like the circle that I have on the top or the bottom. Okay, let's see how good that one will look. Okay, so again, I'm going to cheat a little bit here, attempting to copy an outline first. Let's see if we can get that. This is tough. I think right there is going to be my best shot. All right, and then as far as cross section, oh, we just sort of have to choose, right? Let's assume there'll be a mark right here, maybe one there, and then what I really need to do, oh, I think I can cheat with this too, because I've got the circle. I've got the circle, I can copy that. Okay, so not too great. You know what I'm gonna do is I'm gonna move that one out just a little bit. Because I don't like the fact that it makes contact at the same point. Let's do that. Okay, that looks pretty good there. All right, when it slices through horizontally though, your cross section is gonna end up looking identical to the top base and the bottom base. What'll be interesting, what would really be interesting is if we didn't use a horizontal plane, like what would that look like? What if we came at it at an angle? Okay, and you can have angles in all kinds of different directions. Maybe you intersect that back corner a little bit higher and come out in a lower spot there, and you can create some unique shapes from these things. Yeah, and then for the cylinder, if you don't use a horizontal plane going through it, but if you cross it at some sort of an angle here, you would actually end up getting an ellipse. You'd get an ellipse from that. For example, too, we're going to take a look at a bunch of pictures of solids that have been intersected with planes and then just identify the type of cross-section that we get, like what's the shape look like that we end up with. Okay, so for the first picture, what we have is a hexagonal prism. Okay, it's got hexagon bases, the whole thing is a prism. It appears as though the plane is going through this vertically here, which means that the cross-section, see if I can even highlight it here, the cross-section there, I don't know if it's good to shade it in, I'll just go ahead and do it anyway. The cross-section that you'll create here will just be a hexagon. It is going to be, assuming that it is perpendicular to what would be the base there, then what you end up with is a cross-section that looks exactly like the hexagon bases on the ends. Okay, in the second picture we have a triangular pyramid. If you slice through that, it appears as though it is probably horizontal to the base. It might be at a slight tilt there, but if it is horizontal to the base, you're going to get a triangle for your cross section, and that triangle would not be identical to the base that you have there, but it would be proportional to it, with the assumption that this is running parallel to the base. If it's at a tilt, then you just get some other type of triangle. But otherwise, kind of a neat thing here, it would be similar to the base that you have there, meaning proportional. All right, a cylinder cut at a different direction. Previously, I had shown it with the horizontal plane, which gave you a circular cross-section. If you go through it this direction, you actually get a rectangle. You can get a rectangle in there. Okay, so that one was a triangle. And there is a chance that it is similar to the base. I'm going to add that in there, that it's similar to the base. Possible, it doesn't have to be. Over here, we get a rectangle. Okay, largest possible rectangle would go through the center. You can then create some smaller ones. They'd all have the same height, but they would get skinnier as you go through them. A cone, if you pass through it parallel to the base, you get a circle. And of course, all circles are going to be proportional to each other. Nothing real special with that. But if you were to go through this at an angle, at a slight angle, you can actually create an ellipse, which is really neat. Or if you do a perpendicular to the base of this thing, you get a really interesting one, which is by definition, and this is oddly true, but by definition will be a parabola, the graph that you get from quadratic functions. If you go vertically through this, you end up creating a parabola. Okay, so this will be a circle, but you can get those other shapes there. You could get an ellipse, or you could get a parabola. A sphere, if you slice through it, really cool thing about that, no matter where you go through it, you get a circle. no matter where you go through it. If you go through the very center, you get what is called the great circle. You get the great circle, that's the biggest possible one you could make. But if you slice it any other spot, you try and slice across the top, a little bit of an angle over here, you're gonna get circles just of different sizes. All right, and then F, we're gonna go back to the cube and show you that you can create some really neat things here. If you cut at this somewhat unusual angle here, you can actually create a trapezoid. You're making contact with 4 of the sides, through the top, through the sides here, and then out the bottom, just a little bit closer to the corner, and you end up with a trapezoid. You get a trapezoid in that picture. Here's your circle. Last but not least, you can take a 2-dimensional figure, and if you rotate it around an axis, you can actually create a solid. Okay, very practical thing that you will see in calculus a couple years from now. A solid of revolution is a solid that can be formed by rotating a 2-dimensional shape around an axis of revolution. Okay, so in the picture here, which is a building picture, this would be your axis of revolution. We start with a rectangle that's just attached to the side of it. And if you start to rotate, to spin this around, it carves out in space a shape. Okay, so here it's partly rotating. It began right there. It's rotated around that way, so not even halfway yet. But as it's rotated around, it started to carve out or maybe scoop out some space, which is beginning to take on the shape of a cylinder. If you get all the way around the figure, you do create a cylinder. All right, so with this, you can create a good number of shapes, but all the shapes are gonna have this sort of roundness to them. Okay, so you've got the cylinder, right? You could also do a sphere, you could even do a cone, and then you can create really interesting figures that don't have to be traditional shapes like a rectangle or a square, or what we're gonna look at here, a right triangle. You don't have to take traditional shapes and spin it around, but you can take anything you want and rotating it around an axis, and you can create that somewhat rounded 3-dimensional solid. For example 3, if we take a right triangle and an axis of revolution, we can create a solid that we are fairly familiar with. Okay, so let's start with axis of rotation. So we're gonna use a right triangle. What I'm gonna go ahead and do is use one of the leg lengths as a tangent side to this axis here. Okay, so let that be a leg length. Let that be the other leg length. You've got your right angle here. This could be the hypotenuse. Okay, and if you rotate that figure around, if you start to spin it, you start to spin it around and it begins to carve out into space. I'll go ahead and add a little, what's the measurement here I actually got? It's about 1.5 if I'm a bit generous with that. All right, and I'm gonna go ahead and just add a little dotted line here. I can take that out in a minute. But as it carves around, it will definitely reach out to that spot. The bottom is gonna create that circular shape that you have here with the cylinder. I don't wanna actually draw a circle because that'll look a little bit weird. So sort of just need a guess on this part here, the depth. And that's pretty good. I'll take it. I'll go ahead and move my little arrow out of the way though, just a bit. Maybe move it to the bottom of the figure. Carves that out nicely. I'll take this out, doesn't need to be there. And just change at the bottom a little bit to make it look slightly better. Yeah, we're gonna rotate it all the way around and carve out ourselves a cone.
Later, blah.